we've got y equals cosine x, y equals sine x, x equals pi over 4. Sine curve, cosine curve. I'm going to stop right there because it is x is equals pi over 4. So pi over 4, comma 1 over the square root of 2. As of now, you're able to find and shade the enclosed area when you draw the curve, those who draw the curve, but you're still having problems in terms of putting the outer inner curve. So, first question, are there any restrictions in the problem? No, I'll take that back. We'll do the zeroth question first. Zeroth question in this problem, should the strip be horizontal or vertical? Vertical, that must be your first question. Spinning it this way, so this, spinning down this way, so vertical. I'm going to arbitrarily put my strip right there. So dx, good. If that is dx, volume is integral dx. Since it is dx, the limit must be 4x. Good. So from 0 all the way up to pi over 4. Good. Make the same mistake twice. And pi outside. Good. All we have to do is find the outer radius, find the inner radius, subtract. Okay. Well, inner part of the washer, outer part of the washer. Correct. If you don't see it, showed you last time, you can use sort of a reflection. So sine, then cosine. Good. There is your strip. That's your thickness. Good. That is the washer that I'm looking at. So for a dx, one curve is the outer curve, the other is the inner curve. By curve, I mean the washer, the circle in the washer. So the first curve, let's go that far. Right here. The inner curve has a radius of that. Yes, the inner circle. The outer circle will have a radius of that. Yes, no, maybe. So, since we are moving the strip about the x-axis, as you move the strip along, the radius is going to change. Do we agree? So if it is changing, what is it changing with respect to? Which function? Good. Moving this. X. Well, it's moving this way, right? But the radius is changing. Like what value? That's what I'm asking.
Sine x.
Sine x, this curve right there. So the inner radius is sine x. Outer. This was inner, outer. as I move from 0 to pi over 4, the radius is changing with respect to which function? Cosine x. So the outer one is cosine x. Good. Okay, great. We have the radius, all we have to do is square. Outer radius square minus inner radius square. Cosine squared x minus sine squared x. I messed up that picture. How bad. So here comes integration. There is an easier way to do it, there is a hard way to do it. Have to choose the harder way. Even though the thought process was correct, you did everything right. But you kind of made it unnecessarily difficult. I'll explain what we did. Carter took cosine squared x, wrote it as 1 plus cosine 2x divided by 2, yes? And this as 1 minus sine 2x divided by 2. I think so, yeah. But that's not necessary. Reason being, cosine squared x minus sine squared x is actually cosine 2x. Right? So I can simply change the integral like so, put it as cosine 2x dx. That's what I'm doing. Yes. It's in my table of the approved table. It is in there. What is the integral of cosine 2x? I wrote this as tips and tricks. Sine 2x, is that it? You sure hope so. Something's missing.
Over 2.
Over 2. X is equal to 0. X is equal to pi over 4. Lower limit, if you put x is equal to 0, sine 0, 0. Upper limit, if you put pi over 4, you'll get pi over 2. So pi times sine pi over 2 is 1. 1 over 2. So we get pi over 2. Look at Spam. Fisher, Illinois. I should pick off and leave it as this and teach calculus. Here we go, Luke. I will try to try to draw this picture better. It looked like Batman. Can I erase this side? So we're going to do the second part. Y suits me to now, nothing's going to change there. Agree? Yes, well, maybe. X is equal to -2. Well, last time, x is equal to +2 was a vertical line parallel to the y-axis. This time, it is y equals -2. Horizontal line parallel to the x-axis. Good. So about the x-axis, parallel to the x-axis. So in terms of the setup, it is exactly the same. Good. So where did the strip go? We'll start with that. Was it horizontal? Was it vertical? In that case, it was vertical. Y equals -2, parallel to the x-axis, same process. So the strip has to be vertical. Are we good? Okay. Last time when I drew the strip, I drew from here to there because I spun it this way. Agreed. Now I'm spinning it from there. Draw the strip. Last time, stop right there because y equals 0, x-axis. This time, how far should I go? Tell me when.
Y equals -2.
Okay, I stop right here. If you have difficulties, you can do that one. Oh, this one. Or devil's horns, either would work. Good. Not symmetric, but hypothetically symmetric. And you are putting the strip. If you put the strip, that is good enough in my opinion. You don't have to draw this. I'm going to mess it up. So I'll just leave it as is. Don't want to repeat that. Previous case, stopped at x-axis. This time, it is going all the way down there. Good? Yes, tell me. Okay. Who can tell me what the setup should be? So, if I pick that strip, I would like to know the radius. So, the inner part is right there, inner radius. That is the outer radius. So, from the axis up to that point, in the previous case, we simply traced cosines. Agreed? I am adding a tiny bit to that original value because of the shift. How far did I add? Well, I added 2 units, correct? So 2 plus whatever I had originally. So R out for this case would be 2 plus cosine x. Reason being, from here to there, I have 2 units. From there to there, I have cosine x, which I had no time. I do. For the inner curve, this part doesn't change, 2 units, but that part, that part right there is traced by sine x. So no matter where you place this strip, that radius is defined by the inner curve, which is sine x, and its radius gets increased by 2 because you shifted it down. So the inner radius would end up being 2 plus sine x. Good. Now that you have the inner, the outer, rest of it easy. All you have to do is integrate. We know part of the answer already from the previous problem. 0 to pi over 4, 2 plus cosine x squared. Yeah. Minus 2 plus sine x squared. In outer radius squared minus inner radius squared. Entire thing multiplied by dx. Good. How do we integrate? Towards. There's only one way. I don't even hear cricket. How do we integrate? Wow, no one wants to pass this class. Okay, distribute for whatever. 4 plus k sine squared x plus 2 k sine x. 2 times 2, 4 cosine x, blah, blah. Minus the second part, 4 plus sine squared x minus, my brain's going ahead of me, plus, which would eventually become minus 4. And I have 2 plus cosine x times 2 plus cosine x. Okay. Let's go ahead and apply the negative or distribute the negative sign. 4 plus cosine squared x plus 4 cosine x minus 4 minus sine squared x minus 4 sine x. What happens to the 4s? What happens to the 4s?
0.
Make it with it. No one got it. It's okay. What happens to the 4s? Still didn't get it. Moving on. Pi 0 to pi over 4 cosine squared x minus sine squared x. The other term would be 4 cosine x minus 4 sine x. Good. 2 parts integrating the first one, second one. Well, I know the answer to the first one already from the previous calculation. It is pi over 2, including that pi. So pi over 2 for the first integral. The second one, pi 4 cosine x minus 4 sine x dx. Good. Where is that pi over 2 coming from? Previous part. The integral, when we integrated cosine squared minus sine squared, I had a pi outside, pi, and that was 1 over 2. I took that pi, moved it in. So pi over 2 from part A and the remaining over there. Pi over 2 plus, pull the 4 out, you'd have 4 pi. Time to integrate, x is equal to 0, x is equal to pi over 4. What is the integral of cosine? An integral of sine, negative cosine. Okay, lower limit, upper limit. Plug in the upper limit, sine pi over 4, cosine pi over 4. We did this earlier. What is sine pi over 4? Cosine pi over 4. Minus the lower limit, sine 0, 0. Cosine 0 is 1, since you are subtracting, I'll have negative 1. Good. Now do you see what I started, where I started? That's the answer to the area that we found earlier. So pi over 2 plus 4 pi, 1 over root 2 plus 1 over root 2 is 2 over root 2 minus 1. That's the area we had at the very beginning. So now the volume is pi over 2 plus that bit right there. So, key parts to know. We will do 1 or 2 more problems on this. You've got to understand how to find or how to set up proper notified radius. As long as you find the inner, outer radius, process is easy. The strip part, all you have to do is know that the strip is moving along the x-axis.
That
It will walk about x. Then, if you have any horizontal line, it is the same slope. You are moving it about the x-axis because the horizontal line is parallel to the x-axis. Good? Revolve about x, horizontal line, same thing. Same logic applies the other way around.